This is a sum on circles. In this figure, O is the center of the circle. Angle DAE is 70. So I'll mark angle DAE. So DAE. Now this angle is 70 degrees. Find, giving suitable reasons, the measure of angle BCD, which is BCT. It is this angle. I'll mark in red. So I want this angle. BOD, mark in yellow. And angle OBD, I'll mark in green. OBD. So I need these three angles. So how do we do that? We start with this angle 70 degrees, which is given here. So if this angle is 70, I'll mark in pink. This angle should be 180 minus 70 because BAE is a straight line. So when something is a straight line and you know one angle, so if this is 70, this has to be 110. Because it's a straight line, the angle here at A has to be 180 degrees. So 110 plus 70 is 180 degrees. So this pink one is 110. Pink is 110. Now, so the reason here is very clear. It's a straight line. Now, if you consider this quadrilateral ABCD, it is the vertices are touching the circle. They are inside the circle. ABCD is a cyclic quadrilateral because it is inside a circle. The vertices A, B, C, and D are touching the circle. So opposite vertices are supplementary. So which means A plus C is equal to 180 and B plus D is also equal to 180. So this is the property of a cyclic quadrilateral. Just for clarity, I'll show it here. So this is a circle, and if I randomly draw any quadrilateral inside the circle, it is called a cyclic quadrilateral. So this plus this would be 180 always, and this plus this would also be 180. That's why if the pink angle is 110, this one, the red angle, has to be 70 because they have to add up to 180. So I'll mark in red, this is 70. So this is 70. Now, if this is 70, the yellow angle has to be 140. I'll tell the reason. Because the angle at the center is double the angle at um, at the circle. I'll show by example. So the angle, so the actual explanation is, if this is a if this is the center of the circle, the angle subtended by an arc, so the angle subtended by an arc, so this is BD in our case, BD. So the angle subtended by the arc BD on the circle, so we are talking about this angle, angle C, is half the angle subtended at the center. So which means if this is x, this would be 2x. So this is another theorem we use in the chapter circles. So if this is 70, this has to be 140. Now again consider this triangle OBD. It is an isosceles triangle because OB is equal to OD, because both are equal to the radius of the circle. So the angle OBD will be equal to the angle ODB. I'll mark this in green as well. So these two angles are exactly the same. Why? Because they are the base angles of the isosceles triangle. For clarity, I'll show it here. If a triangle is isosceles, so this is O, B, D. And OB is equal to OD here because O is the center of the circle and OB and OD are both radii. So this is equal to this. So this is an isosceles triangle where two sides are equal. So the base angles would also be equal. So angle OBD is equal to angle ODB. But if you notice, the sum of the angles of a triangle should always be 180. And since angle O is 140, is not visible, so I'll mark in red, mark in black. Because angle O is 140, each of these two angles have to be 20. Because only then they will add up to 180. So 140 plus 20 is 160. 160 plus 20 is 180. So what has been asked is angle OBD. This is 20 degrees. So I'll write the answers here. The first answer, BCD, is 70 degrees. So I'll mark it here. Angle BOD is 140 degrees. And angle OBD is 20 degrees. So these are the answers. So this was a problem given in the 2017 paper of ICSE 10th. Thank you.